stuff. The real easiest way to show that something is inverse is just switch x's and y. Functions are inverses of one another when the x and the y, don't write this down, when the x and the y values in a table flip-flop. What happens is if you plot points on a graph, you'd wind up with some value that's symmetrical about some weird line that's there. These points would be equidistant to each other when you flip-flop x's and y's. Okay? We don't worry so much about the graphs of inverses and how they relate and how do you find the actual equation of this imaginary axis of symmetry until you get to pre-calc. But as you start to look at some of these, because we will look at it on a graph, based on a graphing calculator, to show how the inverses work, you're going to see that there, you can probably visualize that there will be this line that they bend around. Okay. So really the whole idea for an inverse function, all you have to do is look at something very, very easy. One of the first functions you guys worked with were linear functions, y equals mx plus b. And we knew that those guys were functions. We knew that was a function because it passed that vertical line test. Remember that? Yeah. That vertical line test. If it was a function, the vertical line would only touch that graph in exactly one spot all the way across. So if that occurs, excuse me, when we did that, we knew that was a function. To get an inverse then, the inverse of this function, we sometimes write it as, well, I'll show you how we write it in a second. All you have to do is flip-flop x and y. Oops. And re-solve the equation for y. And you get a new equation. Add 3, divide everything by 2. So that means that the two equations, y equals 2x minus 3 and x plus 3 all over 2, are inverses of one another. What this allows you to be able to do, to show that they wind up being inverses, is that you could take, we'll call this f of x, and we'll call this guy f prime of x. That prime value denotes that it is an inverse. You'll see that little tick mark a lot of time for a prime. Okay. If two functions are going to be inverses of one another, if you substitute in one into the other, you will always get the exact same value. Move this up. If I take f of f prime, you'll see it as prime or you'll see it as the -1. You guys know there's a -1 button on your calculator, right? Yeah. X and -1, that means inverse. Do you know that? This has to equal x. And going the same way if you do the other direction. If both of those direct substitutions both wind up equaling x, they're inverses of one another. Okay? So it's a lot of this whole idea of substituting into one another, just like we did yesterday with that f of x, or the f of g of x, or the g of x, and so on. When you did that yesterday, you would write down the first equation and then surround it with the other. For example, if I start with this one, and I want to figure out, to verify that this one works, well, my inverse is this. So I write down x plus 3 over 2. That's playing the role of the value of x, so now I surround it with the rest of the equation. And I get that. So when I distribute in, what happens to the 2? It drops. the 2 drops, and then you get x plus 3 minus 3, which is? Hey, hey, hey. And I do it again with the other one. Well, because they both have to be equal x. The other one says start with f of x. And then I surround it with the rest of the equation. Well, that's playing the role of x, so I add 3 all over 2. Even though I threw that in parentheses just for grouping principle, does it matter? Does it change anything? No. No.
Wait.
I was just clearing off the screen a little bit. What happens here is the -3 and the 3 drop out, and you get 2x over 2, otherwise known as, does x equal x?
No, x equals q.
It marks the spot.
I feel like a pirate now.
Okay.
Do you know why pirates wore eye patches?
I don't.
To give them night vision.
She's not lying.
If you cover one eye, then like it just gives used to the dark, so you can see in the dark.
Oh, yeah.
They switch.
It's like the same thing when
That's
you
why
turn the
pirates
lights
wear eye
off. If you wait a minute, then you can see everything in the dark.
Stop.
But like it's just you always wear the eye patch.
Okay.
And you can see under the cargo and shit. Does that work?
Yeah, it works.
It's like
Because they did
saying
it.
We're not turning off. Anyway, let's just find the inverse, and we'll worry about doing some more verifying of these things in a second. If I want to find the inverse of y equals -2/3 x plus 6, well, what do? Well, you don't want to try.
Not yet.
For sure.
Not yet.
First you cry, then you suck it up, and then you, no,
You switch y and x.
switch y and x. Excuse me, switch y and x.
I said that.
Good job, Field. Welcome.
And then just resolve for y. First step is to do what? Subtract 6. And then how do you undo multiplying by -2/3? Multiply by the reciprocal. In this problem, you can distribute that through because you know that the -3/2 times the -6 will simplify out. And what do you get? You get a +9. Okay? That's how you find inverses. Sometimes you will have restrictions, sometimes you won't. Oh, can I go another one? I'm going to get ahead of you guys. So let's do this verify thing again here. So remember, in order to show that these guys are inverses of one another, both of these two setups have to equal x. And they ask, people ask about this third hour. What happens if they don't both equal x? What happens if one of them equals x, the other one doesn't? Well, depending upon the way the question was worded, if it says verify that they are inverses, you have to get x on both for both of them. If you don't, you done goofed. Okay? Whereas sometimes it'll ask you find the inverse if it does exist. And we'll talk about how you can tell whether or not something exists or not. Yes, sir.
So if you verify it and there's no x, what do you do?
If it's telling you to verify that it is an
Does that mean
inverse,
there is?
then it means there is. Okay. Sometimes you'll have a function where it'll ask you to find the inverse, but the inverse doesn't exist. So take a second and try that. See if you can get them to verify. when you go to start these out, start with the innermost, 1/2 x plus 2, and then surround it with the other equation.
I knew it.
What does that equal?
Oh,
Okay. I do it again.
Can you move?
Wait, what? Start with the f of x equation, which was 1/2 x plus, 2x minus 4. And then I surround that with the 1/2 plus 2. Distribute out. What does that equal?
What does that mean?
It means they're inverses.
Oh, I mean, okay.
And you are happy that you have an inverse.
but I got that they were inverses.
But I found them on opposite sides.
And I guess if you're inverse, wouldn't this be inverses then?
But that's sad.
No, this is
Isn't that the inverse of half
Flip
x?
again.
So you're sad that you have found it. With that,
Well, what if you were sad? Wouldn't you then become happy?
No,
but you're sad even if he is crying, you cannot never not be sad.
Well, if you're, the inverse of sad is happy.
What if you were happy?
But if you have, you're saying the inverse,
Oh, good
So
point,
the
because you're always
sad-
sad while doing math.
well, if you're
So
the
it would
inverse,
be
you're saying the,
inverse.
not the inverse of sad.
What's the top of later?
Oh yeah, you're still sad.
Yeah.
Yeah, never mind. You
you're-
debunked my idea.
But you're always sad while doing math, so if you get the inverse, then you're happy.
Bless you.
Bless
Next
you.
slide.
That's not true. That's not true. I used to do math homework for fun.
I was gonna do something, but I did not. I chose not to.
That was a good choice.
Yes, yes it was.
That is a fun
I almost did it, but I didn't.
story of my life.
What happens when you have powers? Does that change anything? No. Now, one of the things that I would suggest, you were asking about this earlier today also, right about now. When you have fractional exponents, and you're verifying inverses, and you're working with inverses and stuff, don't change them to nth roots. There's no need. Because a lot of times when you're dealing with the fractional exponents, you're going to be working with power to power as you simplify things through. So if you have 1/3 raised to the third power, you know it's going to drop to 1. Or vice versa, depending on the situation. Okay? Yes, ma'am. I don't know. Tomorrow? I don't know. Depends on how far we get through 7-6. I got ideas.
I don't remember.
So your exponent rules here, to verify that these guys are inverses, that means that f of g of x has to equal x, and g of f of x also has to equal x. That's what we're checking to see if these are going to wind up being inverses of one another. Sometimes they don't write it the same. They write it out just to say, hey, f and g are inverses. Show me. So, start with the g and surround it with the f. X to the 1/3 cubed. X. 1/2 cubed. You get x.
This should be easy. When I get to the test, I'm gonna
Go the other direction. Start, yes sir. Oh, yeah. Thought you had your hand. Start with the other one. Surround it with the other equation. Yeah. What does the 1/3 power stand for? Cube root. What's a cube root of 8? 2. Power to power here, I would multiply. 3 times a third is? So I get 2x over 2, which is?
X.
And we've done verify.
Yay!
Yes, sir.
Are we, we're taking a test on this, right?
Eventually.
Okay, because I remember in one class, some complicated, but on the test, would we have like, would it be like a fraction on the outside? Instead of that 3, would it be like 11? Would it be something weird like that?
Would it be
Like
something
8x to
crazy
the
difficult?
11th power.
It depends whether or not I'm going to let you have a calculator.
Okay. If not, will you?
No, I don't know what anything to the 11th power is. I know what 0 to the 11th power is.
Good job, Mr. Murphy.
I also know what 1 to the 11th power is.
I don't know it.
It is gnarly. You're right.
I don't know it 1/3 times.
First time I heard the word gnarly in 15 years.
That's totally too weird, man.
Yes, ma'am. Oh, yeah.
What I kept doing was, remember when you showed us that thing where you just like switch the X and the Y? And then I solved for X again. Okay, so when I do that, I just see if I got that equation there. And if I did, then they were inverse instead of like doing the 2 separate equations.
2 different things, though. If it says verify, this is what you have to do. It's one of those weird things of math. It's because it shows that each one of those composites equal X. Yes, sir.
Are function of f and function of q, are they the same? Are they equal?
The 2 equations themselves?
Yeah.
No. F of x is, they're denoted as 2 different equations. F of x, the first function is 8x cubed. The second equation is x to the 1/3 over 2.
Yeah, but let's say I plug in 2 for both of the x's, would it be the same answer?
No. What happens is there might be a value where the 2 of them cross. What happens is, and this kind of, you can show this pretty decently with,
Because
let me show you, I know where you're going with this. Let's do this. Let's do f of x is x squared. But here's what I want to do. What happens when you have inverse relations? In order for an inverse, or in order for a function to have an inverse, it has to pass what's called a horizontal line test. In order for something to be a function, it has to pass the vertical line test. Well, if that function has an inverse, what's the inverse of vertical?
Horizontal.
Horizontal. So what? Thank you. So what this means is when you're looking at an original function, you look at the graph of that function and you check to see if the inverse exists. So if I look at just x squared, do you guys agree that x squared is just that?
Yes.
Okay. Would that pass the horizontal line test?
yes.
No. This one would not pass the horizontal line test because I would touch it in 2 points. Because the inverse of this would actually look like that, which is not a function. So what happens here a lot of times with power functions, especially even powers is where it makes the most difference, is that they're going to put in a restriction on your domain. So if I look at the inverse of x squared for all x values that are greater than or equal to 0, that's only looking at one tail of that parabola. Do you agree?
Yes.
So if I'm looking at that, let's see how well I can do this. Try to make it. If I use 0, what's 0 squared?
0.
What's 1 squared?
1.
What's 2 squared?
4.
3 squared?
9.
Okay. So there's my original curve. What would the inverse of x squared be for all x values greater than or equal to 0? Flip-flop x and y. We get x equals y squared. How do you undo squaring? Square root. Now this is where that domain restriction comes into play, because if you took a square root over an equal sign, it would always be plus minus. But I'm not worried about the negative value, so I know that my y value is going to be just the positive roots of x. So if I graph that, stick with me, Shinji, I start to see the squishy face. What's the square root of 0? What's the square root of 1? 1. What's the square root of 4? 2. Oops. And then 9 is at 3. What happens is that these they have this axis of symmetry that goes through them, that each of these points on the curve, well, if I drew it better, wind up being equidistant to it. This is why sometimes I actually use graph paper. So they start out and they cross over each other and they just go in different directions. The value of xy on one is the value of yx on the other. It switches. Okay? It switches itself through. It's really easy to show that with a square term. And that's why in order for it to have an inverse, it has to, for a square term, you can only have half the domain. Yeah.
So I have a question about the verifying problem.
Yeah.
What's the point of doing it if you know that you're going to have your x
Because the exploit rules and make sure work, that's all.
Because that's it, it's just.
Yeah. No, it's practicing the exploit rules, because a lot, just tomorrow we use the exploits to solve the way. Okay? That's why you'll see this domain restriction. Now I could have done the domain restriction here for the negative values, and it would have been, we would have been looking at the opposite values and so on. So let's look at this. Let's take the function f of x is 1/2 x cubed minus 2, and then see whether or not we're going to be able to find an inverse prior to doing that. In order to do that, you just substitute those values. You put that into, I shouldn't say substitute, you just put that in your calculator in the y equals table to see if it would pass that horizontal line test. If the original function passes the horizontal line test, then its inverse exists. Okay? So in the calculator, y equals, what was it, 0.5 x cubed? Yeah. Was it minus 3, minus 2? Minus 2. Thank you. And if I graph that, it appears as though that would, in fact, pass the horizontal line test. There's no horizontal line that's going to touch that graph in more than one spot at a time, which means the inverse will exist. So I can go ahead and find the inverse. And I work backwards to resolve for y. The calculator allows you to tell whether or not it's going to pass a horizontal line test. Add 2, multiply by 2?
Yeah.
And then what? Take the cube root of each side, or you can write it to the 1/3 power if you want. Either one is fine. And that gives you your inverse. Remember, you can take it, write it as cube root if you'd like, or if you want to write it as a fractional exponent, that's fine as well. Yes, sir?
All right, so, like, I'm not confused on this, but, like, I don't remember being, like, taught this, but you add 2 first, and then you multiply it half. Is there, like, a rule saying that you have to do that? I know it comes different, but, like, I don't remember it ever, like, you know, like, I always assumed that's the way you did it. I don't
You
remember.
work backwards in the order of operations.
Oh, that's how you did it?
Yeah.
Oh, I never
So
knew.
please excuse my dear Aunt Sally. It's Sally,
No, it's-
Sally, Aunt, my dear.
I get it. I get it.
Excuse, please. Just work backwards.
I never knew that.
You solve like, think of it again, y, you just gotta get y by itself. How would you get y by itself? How do you move, what do you move first?
The 2. The negative 2.
Yeah. So you add it, and then you multiply it by 2 to get rid of the fraction, and then you take the cube root, or you move to the 1/3 power. Either one is fine. Okay.
Wow, okay. I'm surprised I never knew that.
You knew it, you just didn't realize that that's what you were doing. Because it gets ingrained in your brain that you're doing it that way all, for so long. Once you flip-flop things around, like, wait, what?
That's so weird.
Because you know what's weird? You're not solving for x, you're solving for y. That's what's weird. You're not used to doing that.
I didn't
Seriously,
say
that's what most of this comes down to. You're not just getting y by itself.
Why did you say that? I didn't even think about that. What? Like slope, you kind of have to get y alone.
True.
So yes. And slope bothers me a lot.
Let me give you some props.
What if somebody can never
I didn't see myself. I know.
What if somebody can never talk? Like they always talk backwards. Like that.
Would suck.
That's not what I meant.
That would suck and I would not be different.
What?
That would suck and I would not be different.
What if somebody always talk backwards? Why don't you too hard to get your friend? Why couldn't you help them? I just you clearly don't want.
Do those, please. And thank you. No. Yeah, I kind of figured that would be bad. There's not very many sequels that were good. Got probably 2. That's good.
Star Wars.
Austin Powers 2.
Did they make like 4 of those?
They made 3.
I thought they made 4 of them.
What about the Star Wars?
That was a good one.
All of
No,
them.
I hate to say it, that was.
Oh, okay. All right. So. Yeah, you're right.
Star Wars is the only franchise where the sequels are good and the prequels are awful.
Yeah.
You notice they didn't even live in the same town anymore? Yeah, then all of a sudden it looked like California. There's palm trees. They didn't even try. They're just writing that. They wrote that one off.
Which one?
Don't worry.
What movie are you talking about?
How many times have you seen that?